Ogden, and this is my Motion of Falling Objects Lab report. And so these are the videos I decided to analyze. This one is a small ball. I'll show this. And my slow moving object was a frisbee. So next I made a computational model for both the frisbee and the ball. And this only included the effects of gravity. And so what I did is I changed the initial position vector to whatever I have observed in my video. And I also changed the time to whatever my video was. And then I took account gravity right here in my code. And I will run this. Alright, so next I did the same thing, but I took in account for drag in my code. And so I did the same thing with like the initial position vector, but I also calculated right here drag, and I added the force of gravity and the force of drag, and that's the net force. And I'll run that. So I also did the same for the frisbee, but I didn't need to show 4 programs. You get the idea. So then I compared my model to my observations by plotting them all on position versus time. And as you can see here, here's the ball, gravity, position versus time, and this is just taking in the account of gravity, not drag. And they're very similar because the ball had little to no drag, and these are even more similar because it accounted for drag over here. And then for my frisbee, this is the frisbee gravity, position versus time graph, and you notice that tracker, my observations, is a little slower than my model, because my model does not take into account drag yet. So when my model does, they seem to be very, very similar. So for the what if question, it asks if the slow object is thrown down, will it reach terminal velocity? So yes for the drag model, but no for the gravity model. And get that out of the way. So as you can see, the drag one, if you throw it down, I think I set it to the velocity to -10 meters per second. So that's a real force that it was thrown down by. But if you do it over an extended amount of time, maybe like 20 seconds, it does reach terminal velocity, whereas gravity does not. And the reason it doesn't is because it just keeps accelerating because there are no other forces acting on it. So that is all. Thank you very much.